This is code reviews are useless, or maybe I should be a little bit fairer and say code reviews are mostly useless. We're at Code Quality Conference 2024. It's Thursday, June 27th. My name is James Powell. You can follow me on LinkedIn. There's also a QR code that you'll see in the presentation with a couple of links to some of our materials. There's one disclaimer I want to share with you before we get started. First, I'm going to share with you a couple of very strong opinions about the process of code review and how we conceptualize code quality, and where I choose to include examples. They're going to be Python examples. And I know a lot of you are C# programmers, but I think you'll be able to squint a little bit and get a sense for what we're aiming for. Here's the question upon us. Are code reviews a useful activity, or are they completely useless? And it's my view that they're pretty much useless. Here's my proof. I'll start with a little bit of evidence. My first piece of evidence is you've all had this experience where you were part of a code review and the change itself was 5 lines of code long, and people litigated every single minute detail of that code change. They said, oh, in PEP 8, there's supposed to be 2 spaces between class definitions. Oh, you need to write this in this slight way over here. Oh, don't use a comprehension, or do use a comprehension. And it became a long, arduous process. And then maybe a week later or 2 weeks later, you were part of a code review where the change was more significant, 10,000 lines of code. And the response you got was, looks good. Okay, fine. And you might think, if code reviews are an actual useful, real process, surely the 10,000 line of code review would be a much more engaged activity than the 5 line of code review. Surely, if we're litigating every single line in a 5 line of code change, then there must be a lot that we can say about a 10,000 line of code change. And yet, in practice, this doesn't seem to be the case. The other piece of evidence I'll share with you is, if we think of code reviews as a process by which we can assess the quality of some code and determine whether that code is ready for inclusion in some production system, then, well, why do we need such a detailed code review process? Code quality is very easy to assess. In fact, I can tell you, in the span of no more than 1 sentence, the difference between good code and bad code, as I have seen this in almost every code review I've been a part of. And you can say the same thing. We don't need books on what constitutes better code quality, cleaner code. We don't need long, detailed arguments. Good code is code I wrote, and bad code is code you wrote. And unfortunately, in a lot of code reviews, this seems to be how it plays out. And so, given these 2 pieces of evidence, I assert that code reviews are completely useless. That's my proof. However, because we're at a code quality conference, I think it makes sense that we should take a step back and we should litigate these points a little bit more delicately. We should go through each one of these points and really get a better understanding for, well, are code reviews useless inherently, or is it a consequence of the surrounding environment? Why is it the case that a 10,000 line of code review is considered to be a burden? Why is it the case that when you see that 5 line of code review and it's Friday and it's 3 p.m. leading into a 3-day weekend, you say, well, I only got 2 more hours. I might as well cite chapter and verse for all of the things that are wrong in this small code review and really grill the junior programmer who submitted it to me. And yet when you get the 10,000 line code review, you say, it's 3 p.m. leading into a 3-day weekend. Is this really what I want to be doing? Is this really where I want to spend my effort? And you say, looks good, let me just head off early. Well, if it's the case that the code review is seen as a burden, then it's likely the case that's not a particularly useful process. If you're regretting code reviews, if you look at all of the work that you have to do as part of a code review and it's something that you don't look forward to, it's not an opportunity for improvement, then it's probably the case that we're approaching this wrong. If we think about code reviews, and especially long code reviews, as things that require a lot of reading, or a lot of context, or a lot of effort, well, it's definitely the case. 10,000 lines of code. You need to read through every single line there. You need to have all the implicit context of every change that was made. It's a huge amount of effort. And you're left asking yourself, why? What's the point? Well, I think that code reviews are often rendered useless as a consequence of contextual factors, specifically cultural factors in an organization. That is to say, with the lack of a culture of training, a culture of learning, a culture of knowledge, and a culture of quality, it is very difficult to make code reviews a useful practice. Let me go through each one of these one by one and give you a sense of what I mean. So what do we mean when we talk about a culture of training? Well, here's an example. Let's say you have that 5 line of code review, And in that, there's 2 lines that look something like this. I said they would be Python examples here. And the person reviewing your code looks at that and says, no, I don't like that syntax. That's too new for me. I really didn't learn Python after Python 3.6, so the equal sign and the F string is something I'm not familiar with. I don't like it. Figure out how to rewrite that. And the exercise turns into one of those guess what I'm thinking types of exercises, which are extraordinarily frustrating. You say, if you don't like the way that I wrote my code, if you're not a fan of the stylistic choices I've made, don't make me guess what stylistic choices you would make. Why don't you just accept it if it's functionally correct and then go fix it yourself? You can submit your own PR with any changes that you want. The guess what I'm thinking style of code review is definitely one that all of us have experienced, the one that we definitely want to avoid. What might be a more pleasant experience is the let me show you how I'd like it to be experience. And if it's the case that the code review isn't well, you wrote the code in this way, but let me show you the style that we use in our code base. Let me show you the practices that we have, or let me show you what constitutes consistency across all of the other code that's been written. Well, maybe that's a better code review practice. They might say, you know what? Instead of that comprehension, write this as a for loop in this formulation. Saving yourself 1 line of code really doesn't benefit anybody. And just using syntax because it's there is definitely not a benefit. However, what's missing here is the culture of training. When we see things in a code review, we really need to use these as an opportunity to train, especially junior programmers, in what is acceptable within our organization, what approaches that we want to use, and how to use these tools better. A better form of code review should be, let me explain to you how I'd like it to be done. Let me explain to you the foundational concepts for why it is the way things are done the way they are. And so in the case of this 1-line complaint, we could say, well, you know what? If we think a little bit about how Python works, a comprehension is supposed to express to the reader of this code that it's building something. In this case, a list comprehension builds a list, whereas a for loop is to express to the reader that it's performing an action. And if we think about the change that you had, you were printing things to the screen, you're not building something, you're building a list of none values. Nobody wants to use that. You're actually performing an action. And through this explanation, we can share with them not only why it is that the code that they've submitted is unacceptable, but also what they can do to generalize that learning to make sure that they approach the problem better next time. Instead of always trying to guess what it is you want until they've figured out how to mimic you, they can understand the core principles that you're using in order to deliberate whether this code is good or bad. And if it's the case that such principles do not exist, maybe you're just nitpicking. And maybe it's the case that as part of the code review process, you shouldn't really be nitpicking these small stylistic details. Now, some of you might try to take it maybe a little bit of a step further and say, oh, well, in an even better organization, could we make this a discussion where we discuss how something should be done rather than having the code reviewer explain to the person under review? And unfortunately, I do think that that is likely to be unrealistic, especially in the case of junior programmers. It is very much the case that as part of a code review process, we're establishing that there is some hierarchy. There's one person who reviews and one person who is being reviewed, even in the case of a pure code review. And it's very likely to be the case that if it's a junior code review, well, the junior might be missing some of the important context or this important perspective. It's often the case that we see junior programmers will say, oh, you know what, let's just fix everything. And you say, well, hold on a second. We tried that 10 years ago. That's not quite the direction the business is taking right now. There's a lot of details that they may need to know in order to be able to effectively process what something should look like. And so I think it is appropriate, even within a culture of training, to still be a little bit prescriptive about this is what we want, rather than having to make every single part of this a discussion, since it is unlikely that some code reviews would actually be able to turn into a discussion where both sides have equal say in how the code will look. Now, there's some cases where, when we take a look at code reviews, we can see that there's a lot of nuance that needs to be added there. And this is important in that culture of training. The reason we want to train people is because we don't want them to just memorize formulations we like, or to rely on standards documents. Oh, it's already documented here. This is how we write our code. Because, for example, if we rely on PEP8, which is largely and erroneously assumed to be a standardized way to write Python, it's not. It's how Python largely should mostly be written if you're contributing to Python itself or the Python standard library. It will give us some guidance where that guidance is wrong. For example, PEP8 says if we want to determine if a structure is empty or not, we shouldn't use the first 2 formulations, checking the length. We should use the last formulation, just converting this thing to a Boolean value. But this is actually bad advice, because if we have a list, yeah, sure, this if clause, the code contained within, will be triggered if this thing is not empty. But if we have a NumPy and D array, this code's going to break. It's going to raise an exception. It's going to tell us that the truth value of an array with more than one element is ambiguous. The guidance that PEP 8 gives us is not correct guidance in this case. In fact, one of the other formulations would be more nearly correct. Now, as you can see, we're beginning to enter a very delicate territory because there's an enormous amount of nuance to this. If we think about the difference between a list and a NumPy and D array in Python, well, a list is some potentially nested grouped collection of elements, whereas a NumPy and D array is a mathematical structure. So if we go back to this area of disagreement in our code review, is PEP 8 the guide that we want to stick to or not? And we say, well, this line of code here that's following PEP 8 is asking, does this list, this container of entities, have any stuff in it? Whereas if we already have an NumPy and D array, this is asking, if this were to work, does this thing have dimensions? That's not a very meaningful question to ask for NumPy and D array. And of course, any subsequent operation that we perform on that NumPy and D array will not broadcast. Obviously, the broadcasting rules won't let you broadcast against something with no dimensions. And so it's unlikely that you would see code that looks like this in generalized numerical computing, analytical, or machine learning code. And so the nuance here is, PEP 8 is wrong strictly, but it's actually mostly right in terms of how we use these things. And no simple sloganeering, no simple one-line message, write it this way, is going to be able to provide that context and that opportunity for growth for somebody who's under review. This context is important to how we do our work, and it makes everything that we do in our work much richer. It makes our understanding of the problem domain and the tools that we use far greater, and it allows us to use these tools more effectively in terms of using them in a more efficient way and also using them in a more precise way. And in a culture of training, we have that discussion. We have that larger context of, well, why is it the way that we might do these things? Now, in some cases, we may cut it short because we don't want to spend 2 weeks teaching somebody every one of the necessary details behind why we do things in one place. In some cases, we might simplify these, but we should always have some willingness to kind of say, okay, this is why things are the way they are. I'm willing to show that to you. And we might then simplify these in the form of general guidances, but we shouldn't confuse those guidances for the training process. We might provide a guidance like, well, library code in which the user, out of convenience, might provide a NumPy and D array that represents a collection of elements, should be handled slightly differently than library code, which uses a NumPy and D array as a mathematical structure. And in some cases, we might go against PEP 8, in other cases, we might not. And through that context, even if those lines of code find themselves excised from the code base one pull request later, the code review process is still a very useful one because both parties have had an opportunity to communicate or to learn more about the underlying technologies and the underlying system, irrespective of whether the code that they've written is code that will be included in the final product or not. Other guidance you might provide is to be aware that EQ may not compose with bool in Python. And these are cases where you might give somebody some guidance on errors that they might see. For example, if you had some code like if x's equals y's in Python, you didn't know what x's and y's are, which is very much a library concern, not really a user code concern. Well, this is actually strictly wrong. And in fact, you even see this incorrectly in the Python standard library, cases where you might, for example, try to create an enum value that represents cardinal directions, and you might want these to be the offsets in R squared. And if you try and create an enum where the values are NumPy and D arrays, somewhere in the code you see something that looks like this, and you get the truth value of an array with more than one element is ambiguous, use any or all, and it breaks. I actually brought this up to a Python core developer, and they gave me the feedback that NumPy is wrong, let's go change NumPy. And this is why in some cases we may need to be willing to have the conversation, but also say, well, hold on a second. We're not going to rewrite NumPy. NumPy was created now almost 18 years ago. It's very unlikely that we can make such a substantive change. And with the perspective of knowing that these tools are so widespread, we have to sometimes just accept that things are the way they are. But we should never shy away from part of that culture of training people to at least give them a little bit of context and a little bit of understanding for why things are the way they are. So what is a culture of training? Well, a culture of training is instilling in people a sense of deliberateness, that the actions that we take are deliberate choices. We're not just writing the code for the sake of writing the code, but we make choices at every single line of code that we make, and there's some reasoning behind it, even if it's the case that we don't relitigate that reasoning every single time, or we don't explicate that reasoning every single time. It is a willingness to share knowledge. Understanding the code review process is an opportunity for you to share knowledge. It's a training opportunity for you to work with your colleagues, even in a peer code review, and to share with them why it is that things are the way they are. It is not an opportunity for you merely to denigrate or to say, this code's not good enough, try and make it better, make it as good as I want it, make it to my satisfaction. A culture of training is seeing that code review is a mechanism, and one of the most important and most common mechanisms by which we share this knowledge, and hopefully capturing and recording shared knowledge in a code review. This is one thing that you can see from failed code review processes. Well, does anybody ever go back to previous reviews and look through them to understand why decisions were made one way or the other? If it's the case that they don't, then it's likely that the code review process is useless. Now, let's talk about a culture of learning, because here we can see another place where cultural misalignment will lead to a code review process that is not particularly useful in your organization. Here's an example. I do a lot of corporate training as part of my work. We do a lot of consulting, we do a lot of corporate training. And as part of corporate training, especially in Python, we want to teach people not only how to use Python, but how to use Python the way that it was designed to be used. Unlike many other tools that are very non-opinionated about how they're to be used, C++ is a great example. Every organization uses their own unique subset of the C++ functionality and says, these are the things you should use, and then these are the things you should never touch. And then the next place you work on a C++ code base, they reverse the things you should never use and the things you should always use. Whereas in Python, it's a much more holistically designed language, and there's a particular opinionated way to go about using Python. And being a good Python programmer is understanding that that way is relatively consistent across all uses of Python, or at least all good uses of Python. One case of that is encouraging people in Python to use iteration helpers. So you provide them with some code that looks like this, that's looking at some values, and it's looking at these values piecewise. It's trying to determine what's the pairwise difference, from -2 to 94, that changed by 96 from 94 to 7. And you ask them, is this code readable? Is this code understandable? And maybe they might say, well, not really, but I can rewrite that code very slightly. I can make the code look like this. And so it's a little bit easier to see that we're looking at previous values and current values offset by 1, and we're looking at overlapping windows. But what you really want to teach them is, well, in Python, there are iteration helpers, things in the built-in like zip and enumerate, or things in the itertools module. And instead of all of these other contortions, we have direct ways in which to write some code that very, very clearly expresses the idea. Look at things in overlapping pairs. Look at the previous value and the current value, then the next previous value and the next current value, without all of that administrative noise of managing that loop state. Now, when we show that to people, what often happens is, we ask, is this better code? And by a metric of how many lines of code it is, it's shorter. But a lot of people very legitimately say, you know what? The earlier formulations are what I'm more used to from writing code in C or C++ or Java. I've never used iteration helpers. It's a very Pythonic approach for solving problems. And as a consequence, I'm a little bit more comfortable with the other approaches, even if maybe you're saying that they're not better. In fact, we even get feedback that says things like, yeah, sure, that's great. That's the way to do it in Python, but I kind of have to know what itertools.pairwise is and that it exists. And as a consequence, well, we try and say, well, if you're learning about Python, then you ought to learn about Python, and this is the opportunity for you to learn that these things exist and how to use them. And I share with them a very genuine rubric that I use for determining what I should include in my code, and for answering that question of, is this code too complex or not? Is this code worth putting in front of a junior person or not? Because, anytime somebody says to me, I don't use fancy features that my coworkers may not know, maybe they're all junior, that feels too wishy-washy and too subjective for me to really be able to say, oh, this is code that's acceptable and this is code that's not acceptable. And so I understand, because originally when we showed this examples, itertools.pairwise didn't exist, so we showed this to them in the context of an nwise that we constructed ourselves, and we get where, if you actually have to look at how all of this stuff works, it gets a little bit confusing. But I think in a code review, complexity can be boiled down to a fairly simple rubric that we can litigate. I think that what's fair game in code is anything that takes me less than 90 seconds to explain to somebody, or takes me less than 5 seconds to explain to somebody, or takes me less than the space of one cocktail napkin to write out an explanation. And if I can explain something under these under these three restrictions, then maybe it's at a sufficient level of complexity to be included. And maybe we can remove the subjectivity of an argument, is this too complex or not? And in the case of itertools.pairwise, I can do that. Itertools.pairwise looks at something you could iterate over in overlapping windows. Here, I could write this on a cocktail napkin, and I can explain this in 2 sentences and 30 seconds what it does. But if we think about the generalized problem lurking behind all of this, what really seems to be the case is a lot of people look at code and they say, I don't like that code. And in my code review, I'm going to express my displeasure on this code. I don't like it. It's too complicated. They might even pejoratively say it's stupid because it's too complicated. And I know they might say that because I know I've said that before. I've looked at some code and said, oh, I hate this. I hate this with all of my being. It's far too complicated. But what I really meant was, I hate this with all of my being because I don't already know it. I hate this with all of my being because, well, I'm not getting older. I sure am feeling older these days, and I'm actually kind of scared of being left behind. I'm scared of being confronted with things that I don't know and I'm not already familiar with. I'm used to the way that Python used to be written 10 years ago, and I'm kind of scared because the ways that people are writing it these ways are very different. And I know that happens because it happens to me all the time. Well, when we think about a culture of learning, distinct from a culture of training, this is one of the important and critical aspects of an effective code review culture. Specifically, a culture of learning is understanding that learning never stops. I know every single day, I might not look older, but I feel older. And I understand that, for all of the years that I've spent learning all of my tools, it could very well be the case that tomorrow Python goes away and I need to learn Rust. Rust goes away and I need to learn Zig. Zig goes away and I need to learn the next thing. And I should be aware of and come to terms with an idea that the learning never stops. It's a consistent thing. It's a constant thing as part of our work. That there are things that I'm not going to know. And it's okay that there's things that I'm not going to know. And there's things even within my area of expertise that I won't know. And it's a very human thing for me to, especially with my coworkers, kind of brush off and say, oh yeah, that was added recently. Oh, yeah, I knew that, even if I didn't know that. And that's a human failing. And it's a fault that I am aware that I have. But it's something which, when I take a step back and I say, well, you know what? I'm not going to know everything. There's always going to be some detail I don't know. This is an opportunity for me to learn something new. A culture of learning is understanding that the learning process is not always easy, even in fields where you have expertise. It can be very difficult and it can be very intimidating, but it's worth doing no matter what. In fact, if we think about it, continuous improvement, continuous learning is our responsibility. It's worth doing no matter how difficult, how intimidating, even though it's something that never stops, and even though I'm only going to discover more things that I don't know. In fact, some people may go so far as to say that learning is above all other human pursuits, that it is the greatest human pursuit, and honestly, I wouldn't go that far. I would, however, say that knowledge and the search for knowledge is genuinely above all other human pursuits, which leads us into a culture of knowledge. And one thing that is critically missing, and unfortunately one thing that, unlike a culture of learning and unlike a culture of teaching where we can try through some deliberate process develop these, the culture of knowledge is actually quite difficult to instill in an organization if it's not already present. Here's what we mean by a culture of knowledge. Well, one of my biggest pet peeves when we're talking about design decisions in a design or code review is when people say things like, it's a series of trade-offs. Okay, yeah, but what in life isn't a series of trade-offs? Everything's a series of trade-offs that added no knowledge, no information. Or when they say, well, use this feature under these circumstances, or you say, when do you use a generator versus a generator coroutine versus some other feature in Python? And they say, it depends. And I'm just thinking, yeah, it depends on what? The knowledge here is giving me some guidance for how to methodically apply some theoretical constructs to reach an end goal, not to just give me some pat statement saying, well, I don't know, it depends. Sometimes it's this way, sometimes it's the other way. And carving out within what is oftentimes a wholly unknowable field, the regions of knowledge that you can find. Another thing that is a humongous pet peeve for me is when I see circumstances where people are relitigating in the sense that it is an interesting, controversial questions that are ultimately and utterly meaningless and are in fact not controversial and not particularly interesting, but are instead almost and completely obvious in their answer once you understand some foundational theory or some foundational knowledge. I recently saw online some people going back and forth on should they parse the output of ls in a shell script, and I just saw, This is hours of human effort, and the answer is so blindingly obvious. This is not an interesting or controversial question that should be getting that much attention. It's really just a understanding of the core concepts and then application of those core concepts, and then we move on with our life. But to give you an example, I want to show you a little bit of code that I was looking at recently, a representative example that came up in some code review that has an enormously subtle bug. This is one of the most subtle bugs that I've seen in code in a while, and probably the only case where we would make use of a fairly recent feature that was added in, I want to say Python 3.7 or 3.8, that otherwise doesn't have a lot of use cases. You're not going to be able to spot the bug, but you can at least get a sense of what this code does. The person's using some kind of functional programming in Python to write a function that performs or calls another function some number of times and allows you to pass in variadic positional arguments, variadic keyword arguments that are just forwarded through. And the bug here is a design flaw. The first two arguments need to be passed positional only. Because if they're not passed positionally only, then if the function that is then being repeated here contains or has an argument called n, that argument n cannot be passed by keyword or without an ambiguity between, wait, was that the n that I'm passing to the function that I'm calling, or is that the n that I'm passing to represent the number of times I'm calling that function? And that ambiguity means that the first of these two calls will work, but the second one won't. And it's a very hard bug to find unless you know how to look for it, unless you dig to the underlying theory. Now, if we take a look at this, we could actually go a little bit further and say, you know what? We shouldn't be doing this eagerly. We shouldn't be collecting this in a list, because who knows if the end user really wants to collect this list. We should make this a generator and just yield these. And you know, if we're making this a generator, why not just represent this as an infinite sequence of function calls and then give them the ability to control modalities externally? Because what if they want to be able to run this function until it gets a particular output, which they wouldn't do in the first formulation without adding modalities? And so instead, we should write this as an infinite loop and then use itertools.islice or itertools.takewhile in order to control the modality of when it stops. And if we're doing that, maybe we shouldn't even do this in the first place. We should just let them write a list comprehension or a generator expression if they want. And this function doesn't even need to exist. Oftentimes, the use of core theory that has been derived by really searching for the knowledge, the meaning behind the structures that we write, leads to code reviews that look like this, where we start by litigating small details in a useful sense, because it gives us an opportunity to better understand some of the constraints that we're operating under and some of the details of our tools, and then melts away the complexity until we discover, oh, actually, we didn't even need to do this at all. This thing didn't have to exist. The code review is moot. We shouldn't even be going in this direction. But I want to back up a little bit to the original bug. And the original bug is probably one of the most obvious bugs, and yet appears all over the place throughout the design of so many tools. It's a classical in-band versus out-of-band encoding problem, where if we think about what an in-band encoding is, it's any case that we could describe as having a single channel through which we're encoding distinct data or distinct data and metadata, whereas out-of-band would mean using distinct channels for encoding data and metadata. And whether we're talking about two data signals or we're talking about a data and metadata signal really just comes down to the case, but it really is, do we need to encode two things in the space of one, or do we keep them separate? And this is a problem that shows up all over the place in very distinct manifestations, and yet is underlying the same problem. For example, all of you have written a shell script somewhere that used find in order to find the files that existed on disk. And then you said, oh, I want to do an operation on each one of these files. So you pipe that to xargs. Let me find out how much disk space is being used by each of these files. Except one of the files has a space in its name, and this blows up in your face. And if you went to your users and you said, well, just don't have spaces in the names of your files, that's probably the wrong answer, because you made a mistake here. And the mistake in the design of this is an in-band encoding mistake. Fundamentally, if we think about how the system shell works on Linux, well, shell scripting on Linux has a single binary channel by which it transmits all information between processes, the standard out on one side and the standard on the other side. And as a consequence, the connection between find and xargs needs to transmit over that single binary channel two pieces of information: the names of the file and the delimiters between the files. The standard on these systems, the standard with these tools, is to space separate these, or to new line separate these. And so we have an ambiguity. Is the space a space separating the different file names, metadata, or is that space part of the file name, data? Classical in-band encoding ambiguity. And every time we see an in-band encoding ambiguity, there's pretty much the same approaches that we take to disambiguate that. In the case of this, we can either partition, we can prefix, we can escape or quote. I'll zero in on partitioning. What that generally means is you partition the space of values and indicate that some values can only ever be data and some values can only ever be metadata. In which case, for the shell scripting example, well, you say backslash and a null byte can never appear in a file name on Linux. A backslash may be able to appear in a file name on other file systems, but as far as I know, there are no file systems ever that allow a null byte to appear in the file name, which means if we delimit them, if we partition the space of all the characters that we have in that singular channel, such that anything that's not a null byte is data, and anything that is a null byte is metadata, the delimiter, well, we can actually unambiguously delimit these file names. If we take a look at the actual tools we use, we'll see that they implement this. Find has a print 0 argument, xargs has a -0 argument, and we've solved the problem. But the point of this example is not to show you how to fix a shell scripting problem, but to show you where foundational knowledge ends up being much more powerful than you think, and why the search for foundational knowledge is a critical thing in your code review process. Because if we think about things like floating point numbers, IEEE 754, and we look at all the bit patterns of our IEEE 754, we will see that certain bit patterns have been carved out. Some represent actual values and some represent metadata, infinities, nans, and payload nans. And as a consequence, IEEE 754 floating point has an in-band partitioning where it can partition this is actual data and this is metadata, specifically nans representing the absence of a measurement. Which is why, if we happen to be pandas users, one of the things that we've almost certainly run into in earlier versions of pandas was, if we had a pandas series, a pandas data frame, or even a pandas array, and we wanted to represent there was missing data, we could do that if it's floating point data, because floating point has that partitioning, but we couldn't do that if it was integer data. Because integer data, well, how do we distinguish, is a 0 value an actual 0, or a 0 representing something that's missing? And as a consequence, we need either some sort of in-band disambiguation mechanism, of which there really isn't a good one, or we need an out-of-band encoding, and we could think about how a capital I in64 type in pandas is that out-of-band encoding. It's something very similar to a NumPy masked array, which represents the missing values separate from the values themselves. It's a classical out-of-band encoding. And despite being in a completely different domain, with a completely different programming language, this is literally the exact same problem, the in-band encoding ambiguity problem and the mechanisms by which we disambiguate, either within an in-band encoding or the reasoning by which we push ourselves towards an out-of-band encoding. As the shell scripting example, two very different domains, two very different problems end up being the underlying same problem that you can unify and take from something that's relatively controversial to something that's just, oh yeah, this is an in-band encoding ambiguity, here are our choices, and methodically work through them. In fact, even if we look at the design of different tools, like for example, our system path on Linux, which is colon separated, or tools like Docker, where if you're mounting a volume on Docker, you have the source and the destination separated by a colon. When you look at this, you say, well, that's going to be an in-band encoding ambiguity, because what if there's a colon in the directory name? Well, if there is a colon in the directory name, you can't mount it in a Docker container. Docker, a tool that was written very recently by very knowledgeable people, has exactly the same flaw as all these other tools because we didn't search for that foundational knowledge, explicate that foundational knowledge, and bring that to light. Because once you see these problems, you can never unsee them. And then you look at the design of better tools, tools like BRAP, and you say, oh, that's why BRAP has separate arguments for the source and the destination when you're doing a mounting here, because there's an out-of-band encoding that is created by the shell's globbing mechanism and the shell delineating these into different arguments of your argv. When you find that foundational knowledge, it's very much the case that once you see these things, you can never unsee them. And this is the value of finding that foundational knowledge. This is the value of making your code review processes an opportunity to search for that knowledge itself, so that you're not just litigating some tiny detail about one piece of code in one system at one point in time, but searching for knowledge that tells you about all instances of patterns similar like that across all projects, across all time. It is often the case that the search for that foundational knowledge, that foundational underlying theory, takes things that were once controversial questions that turned into flame wars in your code review process, with one person saying one thing, another person saying the other thing, and everybody collecting evidence on both sides, but nobody coming to a conclusion, and it turns them into just obvious answers. Here's the methodical approach for understanding this problem. It leads to these conclusions. Maybe both people were right if we take a look at it through this lens and through this framework. the underlying theory is often lurking in plain sight, and yet there seems to be this resistance in the code review process to really dig into what that underlying theory is. For example, one of the other hugely controversial things that I see all over the place that comes up in code reviews all the time, and yet is not a particularly controversial question, is, in this code review, should this thing be a function? And people say things like slogans, don't repeat yourself. Anytime you're in a code review and you're not talking about some foundational knowledge, you're not searching for that foundational theory, but you're instead relying on simple slogans, there's a very good chance that you're misleading yourself. Because there is theory behind this. We don't have to rely on silly things like don't repeat yourself. We could reach back to theory that already exists, like the theory of normalization, where in the theory of database normalization, there's a topic of why we normalize, and one of the reasons we normalize is to eliminate update anomalies. You perform an update on one part of the system, but that update doesn't flow to another part of the system. You update somebody's address in this table, but the mail still goes to the wrong address because there was another system. And that leads us to say, oh, the way we do that is we create a single source of truth. Well, if we think of what a function is a single source of truth. It's a single implementation of some mechanism, such that if that mechanism changes, it changes in one place, there's no risk of update anomaly. Well, that's really what a function is, and all of these arguments back and forth, should this be our function or not? Some of them may be legitimate, but in many cases, we're just dancing around the underlying theory of normalization, the underlying theory of repetition being either coincidental, two pieces of code just happen to be the same at some point in time, or intentional. Two pieces of code are the same because they must always move in tandem, and they must always be the same. If we dig just a little bit beneath existing theory of normalization, we can discover that there's just one tiny amendment to this. The idea that repetition could be coincidental, that two pieces of code that look the same might just happen to look the same because at some point in time, somebody wanted them to be the same, but they could rightfully and very readily diverge. Or two pieces of code must always be the same, and if one changes, the other must change. If you have intentional repetition, then you unify, and you definitely want to write a function. If you have coincidental repetition, then it's likely that you've assessed it to be coincidental repetition by assessing that it's likely to diverge over time, which means that managing that divergence over time will cause modalities to sprawl in the code, likely deep in the code, then requiring you to revalidate things. The two pieces of code just happen to be the same at one point in time. Somebody changes this, but they've already been unified into a function. So somebody adds a keyword argument to this function, but they have to thread that keyword argument 3 functions deep. They have to retest almost the entire framework to make sure this didn't disrupt anybody else's work. And in this case, we can see a deliberate piece of found theory that's not particularly formalized, that gives us methodical guidance as part of our code review process for what we should do, removing all of the subjectivity and all of the controversy, the unnatural, unnecessary controversy that might arise, all of the flame wars that might arise as this. What is a culture of knowledge? Well, a culture of knowledge is about avoiding these intellectual shortcuts, avoiding these slogans. Always be willing to ask why. When somebody says, don't repeat yourself, say, well, actually, I do repeat myself sometimes. And sometimes I do that and it's worthwhile. Why is it that I'm not taking my own advice? Self-reflect and try and figure out, well, maybe I'm right. I'm just phrasing this wrong. Don't repeat yourself intentionally, but do repeat yourself coincidentally. Always dig for knowledge. And that knowledge, and know that that knowledge is often hiding in plain sight, even though it may take you a while to dig for it. When you take a look at a code review, really ask yourself, what is the reasoning behind the advice that I'm given? And is this generalized reasoning? How do I collect all the evidence across all of the things that I do or don't do and unify those into one singular piece of theory? How we go about doing this is actually quite difficult, and I can't really give you a lot of advice for how to develop this culture of knowledge or how to build that knowledge, but I can give you one critical pointer. Typically, the education that most programmers are subjected to is wholly quantitative. They are hired for their quantitative skill. They're hired because they did well in computer science courses, in engineering courses, in math courses, in courses of that nature. And they don't understand that knowledge can take many forms, including non-quantifiable forms. There is such thing as qualified objective knowledge, and understanding that sometimes, while we may not be able to say everything definitively about a particular question, we may not be able to enumerate facts and figures or create formula, we can still formulate rigorous, thorough, arguments about something, making use of qualified knowledge. One thing that I would strongly encourage every programmer who went through a science, technology, engineering, or mathematical background is take liberal arts classes. Learn about history, learn about literature, learn about art, because the kinds of reasoning that are used in those fields are very foreign to us, but they are part of the key to understanding the fundamental epistemology that allows us to really search for knowledge and perform code reviews that are not just litigating tiny details or relying on shortcuts or slogans. Finally, one thing that we are often missing that leads to code reviews not being particularly useful is a culture of quality. And just like the culture of knowledge, it's very difficult for us to instill a culture of quality where none exists. It's difficult for us to create rules or create guidances or write memos that say, everybody, focus on quality. If that culture of quality doesn't exist, I'm not sure how we create it, but I do know that I've seen it exist in some places, and I've seen it fail to exist in some places. But before we talk about the culture of quality, one important thing we should ask ourselves is, does code quality really matter? Because many of you are going to say, yes, of course it matters. Bad code quality leads to bad code that has security faults, that leads to you losing money, that leads to you losing customers. But some of you are also going to say, well, actually, I have some colleagues and they work at a company and their code is atrocious, and yet they make money hand over fist. In fact, between you and me, we do quite a bit of consulting at some very big tech companies in the US, and you may be surprised to learn that at some of the top tech companies, the code quality is not that good, and they still make money hands over fist. And if you were to give me the choice between having $10 billion or really good code, I'm not sure that I would pick the really good code. And so maybe we should ask the question, does code quality really matter, well, to a particular audience? To whom? Does code quality matter to employers? Well, you almost certainly have seen circumstances where a colleague of yours doesn't really know what they're doing, but is able to talk very convincingly, and they're able to get a job. And it's very difficult to measure code quality in an interview circumstance. So maybe it's the case that to employers, they kind of want a proxy for code quality, but also they kind of want somebody who will just do what they're told and will just ship features. Does code quality matter to the market? You know, we could say that if there's poor code quality, it leads to security issues, and security issues lead to bad press, and you might lose customers. But the unfortunate truth about security issues is a lot of companies have had some very embarrassing security circumstances and don't seem to have lost much money at all. Maybe a temporary dip, and then they recover from that. And so oftentimes, if we look at the market, we can say, you know, quality does seem to matter. There are better goods that do better than worse goods. There are better design products that do better than worse design products. But there's also a lot of junk out there that seems to do very well. So it's not certain to me whether or not code quality can be said to uniformly be of importance to the market or not. Does it matter to the project? Well, I would say yes, but oftentimes when I'm working on a project, I'm working to a certain standard, I'm working under certain deadlines, and I know that the project evolves over time. So I know if I ship bad code today, it may very well be the case that in 3 months, I'm going to rewrite it anyway. So why should I put all that effort into shipping the best thing I possibly can, knowing that it's going to be rewritten? Does it matter to my colleagues? Well, I don't want to be I don't want to be chasing after somebody else's code and trying to clean up after that. So I guess it kind of does. But also it's the case that, you know, a lot of the code that I write is really not that important. And as long as it's functionally correct, if it's a little bit sloppy, you know, then just kind of fix it. If there's a bug, we'll fix it. I think when we talk about quality, and I think the key to a culture of quality is really asking ourselves, does quality matter to you? And for all of the other audiences, sometimes it matters, sometimes it doesn't. And we can find evidence and arguments that it does matter or it doesn't matter. And we can find very compelling arguments both ways. But when I think about it deep in my heart, quality matters to me. I want to do my work to a standard. I want to do that work to a standard that I think I can achieve, and I want to push that standard forward. And if I don't do good quality work, I don't feel like I have done a good job, and I don't feel good about myself. And I think that if we're talking about a culture of quality, and if we're talking about caring about quality, it really is something that has to be built culturally from within. You need to find people who fundamentally care about doing good work for the sake of doing good work. So when we talk about a culture of quality, well, you know, it's about working to a standard and wanting to set a high standard for yourself. Now, if we think about it, in the absence of such a culture of quality, in the absence of a culture of knowledge or a culture of learning or a culture of training, what are we really doing in a code review? In fact, I would argue that in those circumstances, code review probably is useless. I'm James Powell. Thank you all for joining me for this presentation. It's been an absolute pleasure.